In this video, we're going to continue our lecture practice problem. Where we left off, we calculated the pH initially at the half equivalence point, at the equivalence point, and after 4 milliliters of sodium hydroxide had been added to about 0.05 molar concentration of hydrofluoric acid. And we left with a question, what would be the pH after about 0.5 milliliters of sodium hydroxide was added? And hopefully now you've had a second to try that on your own, and we're going to come back together and work through it. So what I've written out as our question and what we already know from the problem so far. This includes our calculated concentrations initially of our hydrofluoric acid, our fluoride, and our H3O+. Because when we have hydrofluoric acid initially, since it's a weak acid, it'll be in equilibrium with its conjugate base fluoride and H3O plus hydronium ion. So as we work on this problem, we're going to be adding sodium hydroxide into our current system of hydrofluoric acid and fluoride. That NaOH is going to react with our hydrofluoric acid and form fluoride ion and water. So first, we're going to need to start by determining the number of moles of our sodium hydroxide to add. We're going to use, and this is like a solution stoichiometry problem at the heart of it. We're going to use our concentration and our volume to determine this. So I am starting with a volume of 0.0005 liters, or 0.5 milliliters. And I'm going to multiply that by its concentration, which is 0.35 moles per liter. That's going to give me a number of moles that's 1.75 times 10 to the negative fourth. So this is what is added into the solution. And all of this will react with hydrofluoric acid. So that means we can determine the amount of hydrofluoric acid and fluoride we have after this addition by doing a little bit of stoichiometry. So the next step of this problem is to determine the concentration of hydrofluoric acid and fluoride after we add the NaOH. And so for this, I'm going to do this kind of at the same time and have these going side by side. So here we have, make kind of a table of this. So initially, we have our hydrofluoric acid, and we're going to have our fluoride ion. We know our initial concentration, so let's start there. Our hydrofluoric acid is 0.04435 molar, and our fluoride is 0.00565 molar. We're going to now determine the number of moles we have for each of these. We initially start with a volume of 25 milliliters. So this calculation will look like our 0.025 liters times our concentration. For our hydrofluoric acid, that's times 0.04435 moles per liter. And that gives us a concentration of 0.001108 moles. And for our fluoride ion, that'll be 0.025 liters times our 0.00565 moles per liter, for a number of moles equal to, 0.000141125. So from here, we're going to subtract or add the amount of moles that will react with our sodium hydroxide. So in the case of our hydrofluoric acid, because it's what reacts with the sodium hydroxide, so we have our HF plus, let's do some different color, sorry. So we're going to decrease the amount of moles we have of our hydrofluoric acid by the number of moles that react with the sodium hydroxide. And on our fluoride side, we're going to be adding the amount of moles that react with the sodium hydroxide and the fluoride, or hydrofluoric acid, because that's what forms as a product. Now we've determined what our number of moles of sodium hydroxide is, or I'm sorry, and looking at our reaction right here, we can see that everything is in a 1 to 1 to 1 to 1 ratio, which means that moles of sodium hydroxide also equals the moles of hydrofluoric acid that react and the moles of fluoride that form. If this was a ditriprotic acid, this step would change, and we would need to do a mole-to-mole conversion that wasn't just 1 to 1, instead 2 to 1 or 3 to 1. But since this one is simple, we'll go ahead and over here we'll have our final moles calculated for both our hydrofluoric acid and our fluoride. So it's going to be our 0.001108 moles minus our 1.75 times 10 to the negative 4 moles that react. And that's going to give us a total of 0. Well, here, let's do this in scientific notation. 9.33 times 10 to the negative 4th. Now looking at fluoride, we're starting with our 1.4125 times 10 to the negative 4th, and we're subtracting that one and adding that 1.75 times 10 to the negative 4th to this. And that's going to give us a total of 0.000316 moles of our fluoride. Now, from here, we can calculate our final concentration. This is going to depend on the total volume. That's going to be equal to the initial amount of our hydrofluoric and fluoride solution, which was 25 milliliters, or 0.025 liters, plus the sodium hydroxide solution that was added, which was 0.0005 liters, for a total of 0.0255 liters. So now I can calculate this concentration by taking my moles and dividing it by volume. So I'll have 9.33 times 10 to the negative 4th divided by that 0.0255 liters. And that gives me a concentration of 0.0366 molar. And our final concentration for our fluoride is going to be that 3.16 times 10 to the negative 4th moles of fluoride divided by our 0.0255 liters for a concentration of 0.0124 molar. So now I have concentrations for fluoride and hydrofluoric acid after I've added that sodium hydroxide. And the concentration of sodium hydroxide at this point is 0, because all of it has reacted with hydrofluoric acid and converted it into the fluoride ion. So now we actually have to figure out the pH, but we've done most of the work. For pH, we're going to, let's go here, find pH. we're going to use the Henderson-Hesselbach equation, which is the pH equals the pKa plus the log of that concentration of the base, which is our fluoride ion, divided by the acid, or our hydrofluoric acid. So plugging into this, our Ka that we're using for this is 7.2 times 10 to the negative fourth. So this will be equal to the negative log of that 7.2 times 10 to the negative fourth, plus the log of the concentrations we just calculated. So our fluoride was 0.0124 molar, and our hydrofluoric acid was 0.0366 molar. So this will be equal to 3.14 plus negative 0.47, which will give us a total of 2.67. So our pH, after we've added 0.5 milliliters of our sodium hydroxide, will be 2.67 in our titration. So this is early in our titration before we hit the equivalence point.